Good morning, students. In earlier class, we discussed about the classification of drives, classification of electric drives, and the dynamics of electrical drive system. Yes, and in today's class, we are going to be discussed about the stability analysis of the electric drives. Yes, so in today's topic, that is stability analysis of electrical drives. Yes, so the electric drives are rotational one. Yes, so to maintain the stability in the drives is very, very important. So that is the reason how the drive stability is to be analyzed. We are going to be discussing this topic. Yes, so what is the stability? What is the stability analysis? Is in general, stability is the change of state from one operating point to another operating point in when any disturbances arises. Yes, so generally stabilities are to be defined two ways. That is the steady state stability and transient stability. And based upon these two stability analysis, the drive stability is to be decided. Yes, let us see what is the stability, what is when the system is stable, when the system is unstable. So all these are going to be discussed in this topic. Yes. Yes. So a system is in an equilibrium condition. Equilibrium here in the sense samatulyata. Samatulyata. Yes. So a system is in equilibrium condition if there is no disturbance. No, obviously no doubt in that. So there is no disturbance as long as the input parameters are constant and the system is in equilibrium position. So any presence of the disturbance, the equilibrium conditions are disturbed and the drive tries to take a new equilibrium position under the new input conditions. Yes. So there is no disturbance, the system is in equilibrium condition. If disturbance arises, so the equilibrium conditions are to be changed from one condition to the other condition. That depends upon the new input conditions. Yes. So when the system is set to be stable, yes. So the system is set to be stable if sometime after the appearance of the disturbance, it attains a new equilibrium condition. Yes. So a system is set to be stable after the commencement of the disturbance. The system goes to a new equilibrium position. That is nothing but the stable system. When the system is known as unstable in the sense, after the commencement of the disturbance, the system comes to rest or unable to take the new equilibrium position. That is known as the unstable system. After commencement of the disturbance, the system cannot go for the new equilibrium. Here either it comes to rest position in the sense stop position. Otherwise, it is unable to take new equilibrium condition. So that system is known as the unstable system. Yes. So generally, the stability of a drive may be much affected by the parameters of the motors as well as the parameters of the controllers. All are to be considered into account. So all the parameters of motors as well as the controllers are affecting the drive stability. And the stability of a drive is also influenced by the inertia of the rotating masses and also the energy storage element inductance of the motor. Yes. So totally we confine that the motor parameters, the controller parameters, and in addition to that, the rotating masses of the machines and also the electrical parameter inductance of the motor is also one of the major cause for the drive stability is influenced. Yes. So in general, the motor stabilities are analyzed. Yes. So in general, the motor stability is analyzed with help of the two types of stability analysis. One is the steady state stability analysis. Another one is the transient stability analysis. These two are considered for analyzing the stability analysis of drive systems. Why? Because in some certain missions are analyzed with the help of steady state stability, and certain missions are analyzed with the help of dynamic stability, sorry, transient stability. So let us have a look on the what's the steady state stability and what is the transient stability. Yes, steady state stability. You see here. So how the steady state stability is to be defined is, so if the changes from one state of equilibrium to another state of equilibrium takes place too slowly to have the effects of rotating masses and inductance, then the stability is called the steady state stability. Very clear. Yes. So initially the system is operating without any disturbance. That means that it is in equilibrium condition. So after commencement of the disturbance, the system takes another equilibrium position very slowly, another equilibrium position very slowly due to the effects of the rotating masses and inductance. So such type of stability is known as the steady state stability. Yes. So from the steady state stability of induction motor characteristics, the motor is stable if change in the motor torque following a decrease in speed is such that that is greater than the load torque or smaller than the load torque following in an increasing load. So that may be analyzed in the characteristics you see here. Yes. So let the motor operating at developed torque TD and load torque TL, and the speed of the rotation is omega. You see here the stability of the is, so the stability of the induction motor is, so these are the induction motor characteristics. Induction motor characteristics. It's the torque versus speed characteristics. So speed is from 0 to 100%, whereas slip is 0 to 100% in reverse direction. So this is the load torque, and this one is this characteristics increasing, and then decreasing. This is the motor characteristics, motor load characteristics. Yes. So this is the motor load characteristics, and this one is the load characteristics. So the steady state stability of induction motor is, so is to be analyzed at the operating points A and D, C and D. You can see here. So for the induction motor, the stability of the stability characteristics, you see here, the motor is stable if changes in motor torque following decrease in speed such that it is greater than the load torque or smaller than the load torque following in an increasing speed. So the speed is increasing from 0 to 100%. You see the load, the motor developed torque, which is increasing to its maximum value and then decreasing. So that means that even increasing in the speed, the torque is decreasing. So you see here the intersecting points of A and D. So based upon these points, the stability analysis is to be analyzed in the induction motor. So induction motor stability is to be estimated through these characteristics. So steady state stability is enough to estimate the induction motor stability analysis. Yes. So even the speed increases, the developed torque is either increasing than the load torque, smaller than the load torque. So by the increase of speed. Yes. So let us have a small look on how the disturbance is created and what's the change of disturbance is to be expected. So let the motor operating at a developed torque TD and load torque TL, and motor speed, that is nothing but the omega radians per second. So this is the original system with one equilibrium condition. So after the commencement of the disturbance, these parameters has to be changed into, see, let there be a small variation delta TL and delta TD following the speed variation in delta omega. So initial parameters TD, TL, omega can be changed as a delta TL, delta TD, and delta omega due to the disturbance arises. Yes. So therefore, before disturbance, the torque balance equation J d omega by dt is equal to TD minus TL. And after the disturbance, we have the same equation in terms of delta omega and delta TD, delta TL is to be considered into account. J into d by dt of omega plus delta omega plus TD plus delta TD minus TL plus delta TL. So original load torque and change of load torque, these two both are considered into account. And from this equation, you can only express the variation or disturbance after commencement is, so J into d by dt of delta omega is equal to delta TD minus delta TL is, so this can be also written as, see, J into d by dt of delta omega is equal to, so you have to multiply and divide with the delta omega. So this can be rewritten as d into TD by delta omega, d omega by delta, d omega into delta omega minus d into TL by d omega into delta omega. Just multiply and divide so that you can write in this fashion. Yes, assuming that the increments due to the disturbance are very small and they can be expressed as a linear function of speed. So therefore, this differential equation can be solved with the help of the Laplace transforms. So the delta omega is equal to delta omega into e power minus 1 by j into dTL by d omega minus dTD by d omega. Yes, where delta omega is the initial disturbance in speed. Delta omega is the initial disturbance in speed. Yes, so this has to be reduced to 0. This parameter, this transient or dynamic, is reduced to 0 when this dTL by d omega minus dTD by d omega is greater than 0. Then this disturbance is to be neutralized. Yes, so this is the nature of expressing the steady state stability. And similarly, another one, which is the transient stability. So what is the transient stability? Steady state stability is very clear. Yes, the change of operating condition from one equilibrium to another equilibrium very slowly, that is known as the steady state stability. But transient stability is quite opposite to that. Yes, so what is the transient stability? Let us see here. So the stability of drive is influenced by the inertia of the rotating masses and inductance of the motor changes suddenly. The dynamic is because of the presence of the rotating masses as well as the inductance. So that stability of the drive is changes suddenly, causing the drive changes its equilibrium. Call it as a transient stability. Transient or impulse, both will be same. The behavior is very drastically changes and very fastly comes to stability. Yes or no? So the impulse response is almost similar to that of the transient behavior. Yes. So the behavior may be influenced by the inertia of the rotating masses as well as the energy storage inductance. These two are the reason for the sudden changes. Yes. So the stability of drive is influenced by the inertia of the rotating masses and inductance of the motor changes suddenly, causing the drive changes equilibrium state is called the transient stability. Yes. So in a synchronous motor drive, the steady state stability criteria does not provide any reliable information regarding the stability. Therefore, it is necessary to study the transient stability. So synchronous motor, it is running with a synchronous speed or constant speed. So the motor, whenever it rotates with a constant speed, the steady state stability does not give a proper information because related to the steady state stability. Is the steady state stability analysis does not give proper information about the synchronous motor, so that we can approach for the transient stability analysis. Is so because of the speed constant, and the synchronous motor is strictly opposing the change of speed. Why? Because synchronous motor always rotates with a synchronous speed only. So it does not allow any speeds other than the synchronous. So in such a type of system, any transient or disturbance arises. So how the analysis is to be performed? steady state stability does not give you proper information. That is the reason we can approach for the transient stability analysis, where in transient stability, the changes are very suddenly causing from one weak equilibrium condition to the another equilibrium condition. Yes. So therefore, synchronous motor suggests that transient stability is better to perform the analysis. Yes. So synchronous motor is very sensitive to sudden changes of load because of the hunting problem. Yes. So the nature of hunting can be explained with reference to the power angle characteristics as shown. See here, this is the power angle characteristics. Power angle characteristics. This is power versus the delta, load angle delta. So this 0 and this is the pi. 0 to pi by 2. 0 to pi by 2 is the middle point, and pi by 2 to pi is the rest of this. Yes. So this analysis is to be evaluated. This constant stability of the synchronous motor is to be evaluated with the help of the this power triangle characteristics. So generally in synchronous motor, the power developed by synchronous motor by neglecting the resistance. It is no doubt in that PD is equal to terminal voltage ET into V by XS into sine delta. Yes. So PD is equal to ET into V by XS into sine delta. Yes. So when the power developed is maximum, by keeping the delta LU is equal to 90 degrees. Yes. So under steady state, it reaches to maximum value when delta is equal to pi by 2. Yes. PDM, power developed maximum, is equal to ET into V by XS. So its sine delta is equal to 1 and delta equal to pi by 2. So it reaches the maximum value when delta equal to pi by 2. This is the condition. Before that, the system is stable. After this, the system is unstable. You can easily evaluate. So finally, for stable operation, delta changes from its 0 value to pi by 2. Pi by 2 is the 90 degrees. From 0 to 90 degrees, it will be in positive way. But beyond that, during the oscillations or hunting, delta changes greater than the pi by 2. So this load angle characteristics or power angle characteristics will clearly explain the operation of the drive in stable region as well as the unstable region. So 0 to pi by 2, the drive operates in stable operation, and pi by 2 onwards or beyond that, the motor faces the oscillations or distortions due to the hunting. Yes. So therefore, the stability analysis is one of the good parameter to measure the performance of the drives, because the drives are running with a constant speed. Drives are running with rotational one. So during the rotation with some speed or some constant speeds, when any distortions or oscillations arises, so this may leads to a disturbance. Yes. So that disturbance is to be neutralized over a long time, or whether neutralized within a small time is decided by the steady state stability or transient stability. Yes. So this analysis, the stability analysis of the electrical drives, are to be estimated with the help of the steady state stability and transient stability. And induction motor stability is to be analyzed with the help of the steady state stability, and synchronous motor stability is analyzed with the help of the transient stability. Yes. So thank you. With this, the stability analysis is completed, and tomorrow onwards, tomorrow we will go for the next topic. Thank you. Thank you all of you.